In this section, we'll talk about integer exponents and scientific notation. So let's take, so for example, if we have any positive integer, okay, we have n as a positive integer and our a to the power n. So let me be very specific. For example, can you give me an example of a positive integer? Just give me one example of positive integer. 3. Okay. So let's take, we have n equals to 3. So we have a positive integer and a to the power cube is equals to a time a time a. So we multiply a. How many times? We multiply 3 times. Okay. So in the similar way, so if we have a to the power 5, then a to the power 5 is same as, so we can rewrite this as a time a time a time a time a. We have to multiply our a 5 times. Okay. And here we call our a as a base. So this a is a base, this a is a base, and our positive integer n is exponent. So 3 is an exponent, 5 is an exponent, or we can call power, right? So if we have x to the power, okay, 9, what is base in this expression? What is the base in this expression? X is the base, and what is the exponent? 9 is the exponent. Okay. So the next here, if we have a negative integer as an exponent, like here we have a to the power negative m. So negative m. So which is the, so this exponent is negative integer, and we can rewrite in a positive integer. Okay. So let's take, we have a to the power negative 3. Our exponent or power is negative number. In order to rewrite this as a positive integer, we have 1 in the numerator. Okay, then you write the same expression a to the power 3 without negative sign. Okay, so this is how we can rewrite our negative exponent as a positive exponent. Okay, so one more. For example, let's say we have x to the power negative 9. Now what will be the same expression with a positive integer? So we have 1 in the numerator. Okay, then you write the exactly same expression without negative sign. So you have x to the power 9 but without negative sign. Okay, so this is how we can change negative exponent to positive exponent. Okay, so here we have more examples, and we are asked to write each expression using positive exponent. Okay, so we have 4 to the power negative 2. Now what will be this? So you have 1 in the numerator, then you just write down 4 to the power 2. Okay, so when, or the other way to learn here is that, so if you have negative power in the numerator, then you just switch the numerator and denominator. For example, if we have let's say x to the power negative 2 divided by y to the power negative 3. Now you switch numerator to denominator, denominator to numerator, and when you switch the power also from negative it goes to positive. Okay, so this will be y to the power cube divided by x to the power 2. Okay, so when you switch your numerator and denominator, the power, the sign of power changes. So if you have positive, it becomes negative, and if you have negative, it will be positive. Yes. Okay, so for example, let's say we have positive. So if we have x cube, then we can write this as a 1 over x to the power negative 3. Okay, so when you switch numerator and denominator, make sure to switch your sign. If it's positive, sign of only exponent. Okay, if exponent is positive, if it's positive, make it negative. Okay, and if it's negative, make it positive. Okay, so now let's go to the part B. So in part B, we have 1.45 to the power negative 3, and this is 1 over 1.45 to the power 3. Okay, now here for part C, we just need to have a positive exponent. Now, so we have x to the power negative 4. So what will be the final answer for this part C? So we have y to the power 5 as a positive. So we already have the exponent of a y as a positive. So we don't need to worry about this expression. But numerator x to the power negative 4 is negative, and we have to make it positive. And what will be the final expression? You take this numerator expression to the denominator. Okay, so we will have no any expression. It means we will have at least 1 in the numerator, and x to the power 4 times y to the power 5. Okay, any question up to here? Okay, the next here we have more properties of integer. Okay, and the very first property is that, so if we have, okay, so we do have, so let's take, we have a to the power m times a to the power n. So we have a 2 expression. Okay, so we have a 2 exponential expression. Now, what is the one common thing do you see in these 2 expression?
The base.
Yes, the base is same, right? So for both expression, base is a, and the exponents are different, m and n are different, but the base is same. Now, if you are multiplying, okay, so we are multiplying here, so we are multiplying. So if we are multiplying the exponential expression with the same base, then its product is, the base remains same, and we add exponent. Okay, so this is a condition we use only when we have a exactly same base. So let's take an example. For example, so we have x to the power negative 5 times x to the power 2. So we have this exponent here, we have this exponent here, and both of these expression has exactly same base. Okay, and we are multiplying these 2 expression. Now the product is, you write down the same base, so base remains same. Okay, and you are adding the exponent, so negative 5 plus 2, and this is x to the power negative 3. We always try to have our answer in a simplified form, so you make it positive, which is 1 over x cube. Okay, now the next, if we have, so if we are dividing, so if we are dividing a to the power m by a to the power n, okay, so we have 2 exponential expression, and the common thing is that both of them have exactly same base. Okay, the base is same, a, and if this is the case, what will be the final answer? You write down the base a as it is, and you find the difference of power, so m minus n. So if you are dividing, you are finding the difference of exponent. Now, so let me take the very same example. So let's say if we have x to the power, sorry, not negative, so let's take, we have x to the power negative 5 divided by x square, and this is, we have the same base, keep that in mind, same base, and this is x. Then you write down the numerator exponent minus denominator exponent 2, and this is x to the power minus 7, which is 1 over x to the power 7. Okay, so instead, if we had something like x square, so if we had something like x squared divided by y squared. Can we simplify this expression? So we are dividing x squared by y squared. So what is the common we see in the numerator and denominator? The exponent is same, but is the base same? So base is not same. So there is nothing we can simplify. Okay, so this is the simplified. So this is the simplest form. We are always looking at the common base. If we have a common base, then only we can use these properties. Okay. Okay, the next here. So if we have, let's say, so we have a times b, product of two number, okay, and exponent m. So here we have the parenthesis, okay. So this exponent m is for both of these a and b, okay. So here a always has a power 1, b also has a power 1, right? So you distribute your exponent for each base. So this is a to the power m times b to the power m. Okay, so this is the next property. Okay, in a similar way, if we have the a over b and a exponent m, then we can distribute this exponent m to the numerator as well as denominator. So this is a to the power m divided by b to the power m. Okay. The next here, and if we have an exponent a to the power 1, it is always equals to a, right? Like 100 to the power 1 is 100, 1 to the power 1 is 1, 10 to the power 1 is 1, 1.5 to the power 1 is 1. And if we have exponent 0, so let's say we have a and a to the power 0, what will be its value equals to? It's always equals to 1. Okay, so 100 to the power 0 is 1, 2/3 to the power 0 is 1, x to the power 0 is 1. It's always 1. Okay, now here, and if we have 0 to the power 0, is it equals to 1? This property does not apply when your base is 0. Okay, when your base is 0, 0 to the power 0 is not 1. Okay, so we call this undefined. Okay, and once you start taking higher math courses, you'll understand why 0 to the power 0 is not 1. So make sure to use this property, and the only one case where you do not use this property is if your base is 0, 0 to the power 0 is not 1, but for every other real number, the power, any real number to the power 0 is always equals to 1. Okay, so these are the properties, and with these properties, we will simplify the expression given to us here. Okay. Okay, do you have any question on this part? Okay, so now here for part A, we have to simplify. So we have 16x to the power 10 times y to the power 4 divided by 4 times x to the power 10 times y to the power 8. Okay, so we have a 16 in the numerator, we have 4 in the denominator. How these two are related? So they are same constant, they are the real number, right? And we can divide 16 by 4, and what is that equals to? 4. Okay, now we have this term x to the power 10 and x to the power 10, okay, in the numerator and denominator. Now it means we are dividing x to the power 10 by x to the power 10. So if we have a division and we have a same base, so according to property, we write down the same base x and find the difference of exponent. So write down the exponent of numerator 10 minus exponent of denominator 10. Okay, now for the next, we have y to the power 4 divided by y to the power 8. We have the same base, so you write down the same base y and find the difference of the exponent. So write down the exponent of numerator minus exponent of denominator 8. So this is 4x to the power 0, y to the power minus 4. And what do we know about x to the power 0? It is 1, right? So this is 1. So we have 4 times 1 times. Now we have y to the power negative 4. And your final answer has to be always positive exponent. And how do we rewrite this with a positive exponent? 1 over y to the power 4. So all these are numerators. So let's multiply 4 times 1 times 1, 4 divided by y to the power 4. So this is our final answer. Okay, any question? Now here, let me make a slight change. For example, if we had something like 16 plus x to the power 10 minus y to the power 4 divided 4 minus x to the power 10 plus y to the power 8. How would you simplify? Do we use exactly same step here? Okay. How would you simplify this expression? Now, what's the difference here? Okay, can we divide 16 by 4 and write down 4? Can we cancel x to the power 10, x to the power 10?
Wouldn't it be x raised to the power 10 minus x raised to the power 10?
Okay, so you mean x to the power 10 minus minus 10
minus x. Oh yeah.
Okay, then
So that's x to the 20 x.
Okay, what about for y?
It's gonna be
Y
4
4 minus 8. Okay, how many of you agree on this part? Now, this is not correct. Okay, now here's the C. So let's find the difference at first. How these two expressions are different. In our first expression, so here, okay, just let me write down that. We had 16 x to the power 10 y to the power 4 divided by 4 x to the power 10 y to the power 8. Now, in between each term, so we have 16 x to the power 10 y to the power 4. So in between each term there is positive or negative. But here what do we have? In between 16 x to the power 10 y to the power 4, what do we have? We have a multiplication, right? So it does not, so they don't have a multiplication sign, but we do have a multiplication in the similar way. So we have a 4, we have a negative here, we have a positive here, but in between 4 x to the power 10 y to the power 8 there is a multiplication. Now you can use this property only if your numerator is in a product form or denominator in a product form. Okay, you must have your numerator in a product form. Now you can't cancel 4 and 16 here. You can't divide 16 by 4. You can only divide or you can only cancel if you have your numerator in a product form and denominator in a product form. Okay, for example, let's say, let me take one more. So for example, if we have x minus 2 divided by x, now this is the one case, and the next case x times 2 divided by x. Now in the first case, is our numerator in a product form? It means, do we have the multiplication in between each term? We have a negative, right? So in between x and 2 we have a negative. It's not in a product form, so you cannot cancel this x and x. So if you cancel, this is wrong. Okay, but in the second case, in between x and 2 we have a product, so our numerator is in a product form. Okay, so we can cancel this x, and we have 2 as our final answer. Okay, and whenever you use these properties, make sure your numerator and denominator is in a product form. Okay, otherwise you can't use. Okay, now let's go to number B. Okay, one more. Okay, so if we have x 2 times x minus 3 divided by x minus 3, so what will be the final answer for this part? So we have 2 times x minus 3 divided by x minus 3. So what, is there anything we can cancel? Okay, now that's right. So we have a 2 here, so this is one expression, and let's take this as a second expression. Okay, and we have a product here, right? And let's take this whole as our one expression. And what we have, so this expression and this expression is in, and we have a multiplication here. So since our numerator is in a product form, you can cancel this x minus 3 and whole x minus 3. So we have 2. Okay, so this is not same as 2 times x minus 3. So if you cancel like separately, if you cancel x 3 negative negative, this is wrong. Okay, so we take this expression as a 1 and we take this expression as a 1, and we have 2 here. Between 2 and this expression we have a product here, so numerator is in a product form, so we cancel this expression and this expression. Okay, all right, so let's go to part B. So here okay, now which property do we use here? So we have a list of property from 1 to 7. Now at first, for the numerator, which property do you think we will be using? So we have 3 times x to the power minus 2 and exponent 3. So this exponent 3, is for each term inside the parenthesis. This 3 is for 3, this 3 is for x to the power minus 2. So we distribute, so we give this exponent 3 for each term. So we have 3 to the power 3 x to the power, you are multiplying, okay, negative 2 times 3 is negative 6 divided by x to the power negative 5. Any question?
What about minus 2? The exponential minus 2.
So we, okay, now here, now we have a parenthesis here. Okay, so this exponent 3 is for every term inside this parenthesis. Okay, so this 3 is for this 3 as well as this 3 is for this one. Okay, just let me write down this. So we have 3x to the power minus 2 to the power 3, right? Now can you tell me what is the exponent for 3? If it's nothing, it's always 1, right? So we have 1 here, and this 3 is exponent for every term inside the parenthesis. Now you distribute this 3 for first and this 3 for next. So you are multiplying the exponent, and this is 3 to the power 1 times 3 x to the power negative 2 times 3 negative 6. And here in between 3 and x is the product. Okay, for example, if we had something like 3 plus x to the power minus 2 power 3, now you can't do this one as a 3 to the power 3 plus x to the power minus 6. This is wrong. Okay, it has to be in a product form. Now you see the difference here. So here we have a product between 3 and x to the power minus 2, but we have a sum. Okay, so if you have a sum or difference, we are not using this property. Okay, we use this property only when we have multiplication or a division. Okay, okay, any question for the up to here for the first part? Okay, now the next here, so this is, so we can simplify 3 to the power 3, and what is that? 27. Now we have x to the power minus 6, x to the power minus 5. in between 3 cube and x to the power minus 6, we have a product, so we can use our property. Okay, now so you just write down they both have a same base, write down the base x, then you find the difference, write down the exponent of a numerator -6 minus exponent of denominator minus 5, and this is 27 x to the power minus 6 minus time minus 5, that is positive 5. This is 27 x to the power minus 1. We don't want negative integer, so this goes to denominator. So we have 27 divided by x to the power 1, which is simply x. Any question? Okay, so let's go to part C. Does anyone have any question? Okay, so for part C, so we have 54 times s square t to the power minus 3 divided by 6 gt and whole power -2. Okay, now so we have -2. Now this -2 is the exponent for every terms inside this parenthesis. Okay, and before you distribute, make sure to check whether your numerator is in a product form or not. So we have 54 times s square times t to the power minus 3. We have 6 times g times 3. Okay, you can distribute now, or you can simplify what you have inside parenthesis and distribute the -2 later on. Okay, so let's simplify inside the parenthesis first. Okay, so we can divide 54 by 6, right? And 54 divided by 6 is 9. It's 9 or 8? 9, right? Now, okay, we have s squared, the base is s. Now, do we have any other expression with a base s? No, right? So we write down that s squared as it is. And next we have expression t cube. Now, do we have any other expression with a base t? We have here, right? And its exponent is, if it's nothing means, it's always 1. And it's division, right? So you write down the t to the power minus 3 minus the power of denominator, which is 1. Okay, and we still have g in the denominator, and do not forget about this -2. Okay, the next we have, let's simplify inside the parenthesis. We have 9 s squared, so this is t minus 3 minus 1 minus 4 divided by g. We have -2. Now there is nothing we can simplify more inside the parenthesis. So what do we do now? We distribute this -2 for each term. Okay, you are multiplying -2 and the exponent of each term. So this is 9 to the power. So that 9 has exponent 1, right? 1 times -2 is -2. S 2 times -2 is -4. T -4 times -2 is +8 divided by so g has exponent 1, so g to the power 1 times -2 -2. Since every term in the numerator and denominator, they are in a product form, you are multiplying. Okay, you are multiplying this exponent with exponent of each term. Okay, now we have the negative exponents. That's not what we want. We want a positive, and to have a positive, you switch numerator to denominator, denominator to numerator. So this is this is negative, this is negative. So let's take this to denominator, and this is negative, and let's bring this back to numerator. Okay, so we have g square t to the power 8 divided by 9 square s to the power 4. We know what is 9 square. that is 81 s to the power 4, and this is the final answer. It looks a lot, okay, but once you are familiar with the properties, it's not be difficult. Any question? Can I start the next topic? Okay, so the next one here, if we have a very big number or small numbers, okay, we can rewrite those number with the system called scientific notation. Okay, for example, let's say we have our x, a very small or very big non-zero number. Okay, then we can write this x as a times 10 to the power b. Now here, your a has to be between 1 and 10 if x is greater than 0. Okay, so and a is in between -10 and -1 if x is less than 0. Okay, and b is an integer. Now the b is called the order of magnitude of x. So here let me take an example, then it will be more clear. So we have this number 328.5. Now is this number greater than 0 or less than 0? Greater than 0. Okay, so we will use this part here. So when your x is greater than 0, then we find a. A has to be in between 1 and 10. So what will be a in our case? You take the first digit here, 3. Okay, it has to be in between 1 and 10. You just take the first digit, then you move your decimal to your 3 and write down the remaining digits. We have 285. Then you write down times 10 to the power. Now how far did you move your decimal to the left? That is b. So we moved 2, right? So 10 to the power 2. So at first you have to know whether your number is greater than 0 or less than 0. Okay, now here we have 328.5, which is greater than 0. Okay, so we have to find our a. A has to be in between 1 and 10. So you take the first digit as your a. Okay, so then you move your decimal, okay, after 3 and write down the remaining digit, 285. Then times 10 to the power, like how far did you move your decimal? That will be the exponent, or b. Now for b, so we have 4.69. So this is also greater than 0, right? So this is this is not a big number. But still, if you want to write, you just what we can do here is that, so you just copy the same 4.69, and because 4.69 is in between 1 and 10, okay, then simply write down times 10 to the power 0. Does it make any difference if I add times 10 to the power 0? What is 10 to the power 0? 1, right? And 1 times 4.69 is 4.69. Okay, so this is not a big number, but whenever we have a very big number or a very small number, then we use the scientific notation. Now for C, we have a very small number, 0.00712. So here, this number is less than 0. Okay. Now we pick a number. So our A has to be in between -1 and -10. Okay, now I'm confused with the definition here. Okay, so when we are writing the scientific notation for this one, I don't think that this definition works here. So what do we do here? We find a. Okay, so we take the first digit, so excluding 0. Okay, so our first digit is 7. So write down 7 times 10. Okay, now how far, sorry, 7.1, okay, I'm sorry. So write down 7, then decimal, remaining digit 1 2 times 10 to the power. Now how far we move our decimal to the right? 3, right? And when you are moving to the right, you have the negative exponent. If you are moving to the left, positive exponent. And if you are moving your decimal to the right, make sure to have a negative exponent. Okay, so this is 7.12 times 10 to the power minus 3. Okay, now this definition, so here we can't have negative number. So this decimals, okay, again, it should be something like b times a to the power, sorry, 10 to the power a. So if this is the case, then let's see, our b is an integer, then we have 10, our a is positive if our number is greater than 0, a is negative if number is less than 0. Okay, now for part D, so we have negative 435.6. okay, so here, so what do? You just write down the first digit, negative 4, then write down the decimal and the remaining digits. Now, how far did we move our decimal? We move our decimal from here to here, right? So we move to left. So it would be positive exponent times 10 to the power 2. Right now, yeah, ignore the definition. Okay, so this is how we can write down the very big number or a small number in a scientific notation. So let's do one more. So if we have something like 0.0000285, now how can we rewrite this number using scientific notation? So you write down the first number, which is not 0. Okay, so here we have 2. So you start with 2 point, then write down the remaining digit 85 times 10. Do not forget 10. Now since we are moving our decimal to the right, now how far we are moving? So 1 2 3 4 5. So we are moving 5 units to the right, so it will be negative 5. So this is the case when we have a very small number. Now if we have a very big number, let's say we have 248,900. So if we have 248,900, then we can rewrite this using a scientific notation. Write down the first digit 2, then write down the decimal, remaining digits 489. You can ignore 0 times 10. Now how far we are moving the decimal? So here our decimal, you don't see decimal here, but we can rewrite this as a 0.00, right? So you are moving from here to here. So 1 2 3 4 5, we are moving left, so it would be positive 5. Okay, so this is the case when we have a very big number. Again, it makes us very easy to write down our very small or a very big number. Okay, do you have any question up to here? Okay, now I think this is all about section or point